So this is the node structure for double linked list. Okay, is it visible?
Yes, sir.
Yes, sir,
Yes,
visible.
sir.
Okay, struct node. Then as in double linked list, there are two types of pointers. Previous pointer that points to the previous node, and the next pointer that points to the next node. And between these two pointers, there is a data. So this is the node structure for the double linked list. Okay. Now, a double linked list, it is also termed as two-way list. Okay. It is a more complex type of list which contains a pointer to the next as well as the previous node in the sequence. Okay, so as it points to the previous node with same type, so this is for previous node, and this next is for next node, and this self self-referencing structure. These are your self-referencing structures. Okay. Now, what will be the structure? Let the first node contains the data value. Let the first one contains data value 1. Okay. The second node, this contains the data value 2. Third one, this contains the data value let 3. And fourth node contains the data value let 4. Now, as the last node's pointer, as for as this is the double linked list, not circular, so last node's next pointer is always made null. Okay. And similarly, first node's next pointer, a previous pointer, this will also made null. Okay. Now, first node's next pointer is pointing to the second node's previous one. Similarly, second node's previous pointer is pointing to the first node. So there will be a two-way communication. That's why these double linked lists are called the two-way list. Okay. Is it okay up to this? Now, the previous field of the first node and the previous field, so the previous field of the first node and the next next field of the last node, this will contain the null value. Okay. Now, the previous field is used to store the address of the preceding node. This enables us to traverse in the list in the backward direction. Suppose we in our several examples we are using the PTR, the temporary pointer PTR, and we traverse in forward direction. Okay. Now, if you want to traverse in a backward direction, then the previous pointer will help us. Okay. The previous pointer for every node, these will help us. So PTR is equal to how to proceed in the forward direction, What are the conditions for forwarding? Any idea? So we have to first declare the temporary pointer PTR, okay, and its return type, this pointer is actually this temporary pointer is actually pointing to the nodes. So these nodes are of self-referencing structure. That's why this return type is struct node. Okay. Now, how to proceed? Suppose in case of single linked list, the conditions are while your PTR arrow while your PTR arrow next not is equal to null. Okay. So we have to forward. So the condition for forward is equal to PTR is equal to PTR arrow next. Okay. In case of TLL, a condition will be PTR arrow next not is equal to start. You have to initialize the start struct node start. Okay. You have to initialize this start and PTR. So this is for SLL. Similarly, this is used for TLL. Now these all are used for forward direction, forward movement, forward movements. These all are useful for forward movements. Okay. Now how to traverse in a backward direction? Any idea? Any idea? Am I audible?
Yes, sir.
Now how to traverse in a backward direction?
So just use prev instead of next. Like PTR is equals to PTR prev.
Yes.
Arrow prev.
PTR arrow prev not is equal to something. Suppose you are interested for finding a certain value, then PTR arrow prev not is equal to your value. Okay. So that's why this is called the two-way list. So these are called the two-way. So two-way list. Both forward and backward directions are possible. Okay. Now there are several algorithms. So insert a node at the beginning. Insert the node at the beginning. So this is the node connection. Sorry, this is the list, and this is your start. Okay. This is your start. Now you have to insert, there is another node. Uh, let 5 is the another node. So first you have to create this, new node 5, and you have to put the value 5 here. Now how to insert this 5 in front of the list at the beginning? So what will be the code? Any idea? Anyone? How to insert? কারোর কোনো কথা নেই, চুপ। সতীশ,
Yes, sir.
how to insert at the beginning?
Sir, we have to first create a new node. Then, sir, new node next new node contain a data value,
New node contain data, okay.
and new
That is
node
new node, that is
table.
new node, that is new node data is equal to your value, and
Yes, sir.
and
And sir, new node previous will contain
new node previously contains the
null. Hello,
null, okay.
null. And next will contain the starting value, which is
Next will contain the
start of CLF head.
okay. So first, the new node should be created. Your first task is to create the new node using the malloc or calloc function, using malloc function. Then, as this is the start node, so this connection should be omitted, and this should be made null, okay. This should be made null. This next should be pointing to this one, okay. and and this this previous value of the first node must point to the second part, that is the next part of the new node, and finally drop this s and insert this s here. So this is the algorithm for inserting this node, inserting this newly created node 5 in front of the linked list, okay. So insert a node at the beginning, insert a node at the beginning. So what will be the code fragment? So the code fragment is insert beginning, insert beginning, okay. Start node and start, okay. Start node. So we have to first dynamically allocate the new node. So new node, we have to declare this new node, okay. And what will be the return type? Start node. Now let int n the value, printf, enter the value. So the value is, using scanf, we have to take these values using the scanf in. Now we have to dynamically allocate the new node. So new node is equal to struct node star malloc struct, sorry, size of struct node. Now the inserted value must be in the data part. So must be in the data part of the newly created node. Okay. Up to this, any problem? So your new node is dynamically created. Okay. The previous and next part of the newly created node is made nothing. Now we have to delete. Now we have to delete the cross from the from the previous field of the first node, and there should be a connection. As this is a double linked list, so there should be a connection from the previous part to the next part of the new node. Okay, as this is the double linked list, two-way linked list. Okay, so start previous value. So start prev is your new node, and new node next. So new node next is start. Okay, and finally the previous part of the new node. Finally, the previous part of the new node is made null, as this is your first node. Anything else? Is it fine or anything else? We have to add anything? Suraj, are you there? Suraj, Suraj নেই মনে হয় most probably. Shubham. Shubham. সব চুপচাপ কেন? স্নিগ্ধদেব,
হ্যাঁ স্যার,
এরপরে আর কিছু করতে হবে?
স্যার একবার চেক করি।
এতক্ষণ কি করছিলে?
স্যার দেখছিলাম এন্টার ভ্যালু।
ওহিনী কিছু করতে হবে?
স্যার যে নিউ নোড হয়েছে তাকে এখন হেড বা স্টার্ট যেটা আছে ওটা ডিক্লেয়ার করতে হবে।
Yes.
স্টার্ট ইজ ইকুয়াল টু নিউ নোড।
Start is equal to new node. Okay. So start is equal to new node, and finally return start. So this is the code for insert at the beginning. Okay. Now insert the node at the end. Insert the node at the end. Let this is the nodes this is the node 6. We have to add this 6 at the last one. So what will be the algorithm? Anyone? আজকে সুরজ বা স্নেহা কেউ নেই, তাই তো? এরা কেউ নেই আজকে?
না স্যার মনে হয় নেই।
আচ্ছা, তুহিন 9048, তুহিন 9048, তুহিন left. Tawfiq 9029. So what will be the algorithm for insert at the end? সবাই চুপচাপ থাকবে। শিরিন বলো তো 9061।
Over next. Next.
Sir, like with the one which is null at this point, we'll join it with the head.
Head 6
Yes.
is added at the last one.
No, 6 is
And
added to the last one. Okay, so we'll add the which one that is null, we'll add it to the new node first. Like the 5 is last right now, so we'll add it to 6.
No, 5 is not last.
4
5
is
is the
null.
5 is the head.
Okay, okay. Then since 4 is last, it will have a null pointer at the end. So we'll find the null and point it to 6, like connect it to 6.
So first connection is this, right? So first connection is this. Next. So this is your first connection,
Yes.
right? So this
And
is
then
the
back
first
connection again.
Next,
And we'll connect the 6 to 4 again, since it is a double wire list.
6 to 1. So this is your second connection.
Yes.
And what will be the third operation?
So we'll make the 6 next pointer null. Like if it is temp, so temp next will be null. We'll mark it as null.
Okay, so this is the first operation, the second operation, and this is the. Now, first we have to traverse up to the last point. So insert the node at the end. So insert the node at the end. Struct node. Insert end. Insert end. And struct node. So we have to add, we have to create a new node. That's why this is your new node. So new node, and as we have to keep a track for traversing up to the last one, so PTR. Now return types are struct node. Okay. Next is int n, enter the value, scanf, size of, and data. These are same. So int n and enter the value and dynamically allocate dynamically allocate this new node, and new node data is n. Okay. Now you have to traverse up to the last one. So as PTR is a temporary variable, so PTR is equal to start, and the condition is that while PTR arrow next not is equal to null, we have to traverse PTR is equal to PTR arrow next. Okay. Now what will be the first operation? This is the first operation that there is a first we have to make a connection from the last node's next pointer to the previous field of the new node. Okay. So PTR. So you are now at the last one. So PTR arrow next. PTR arrow next is equal to new node. And at the same time, new nodes previous. New nodes previous. This is the second operation. This is the first operation, and now this is the second operation, that new node's next previous part is pointing to the PTR. So new node's previous is PTR. Okay. Finally, new node next part is made null, and return start. Up to this, any problem? Fine. So insert the node at the end, insert the node at the beginning in DLL. In DLL. Similarly, insert the node at end in DLL. Sorry, DLL. So this is your homeworks. Insert a node at any specified location in DLL. Could you just give me what will be the essence behind this? How to insert a node in any position? Any idea? Let the before. Insert before a new node. Insert before any node, specified node. Let we have to insert this 7 we have to insert this 7 before 3, before the third node. So how to modify? Any idea? We have to insert this 7 before this node, that is in between 2 and 3. Any idea how to insert? Nine zero eight 9082 Shubham. Unmute yourself.
Yes, sir.
কিভাবে ইনসার্ট করব? বলতে পারবে? শুভম? মাঝে মাঝে কি হাওয়া হয়ে যাচ্ছে নাকি? So you have to insert this 7 in between 2 and 3. Okay. So while your PTR temporary pointer, while your PTR, oh, 1 second. while your PTR, that is P, let this is P. So while your P arrow data not is equal to, while your P arrow data not is equal to your value, that is 3, you have to traverse. Okay. Next, new nodes next part. So the new nodes next part is pointing to the PTR. Now your PTR is at this position after the completion of the while loop. While PTR arrow data not is equal to value, you have to forward your pointer. Now after completion of the while loop, your pointer now is at this position, just after 3. Now the next part of the new node is pointing to the PTR. Okay. And this is the pre-PTR. If you want to ignore the pre-PTR, this is the P previous. Sorry, you have to insert the P. This is the PTR. So PTR. So this is PTR previous. So PTR previous, that is P prev arrow next. Is equal to your new node N. So make this connection. So PTR prev next is new node, and new node previous is now pointing to the PTR previous. After that only one connection is left. You have to do that. What is the connection? The connection is that this one. So PTR previous is now pointing to the new node. So there will be total 4 operations. This is a little bit complicated. Please clarify the concepts. There will be total 4 operations. Do you have any query regarding this insert before a node?
স্যার আরেকবার বুঝিয়ে দেবেন?
Okay. Let this is your 2. This is your 2 and this is your 3. We have to insert between 2 and 3. This is the 7. Okay. Now there is a connection inbuilt 2 to 3 and 3 to 2. There is another connections. These are continued. Okay. Now this 7 new node is dynamically created. Okay. This new node is dynamically created. This is the dynamic memory allocation, and after the dynamic memory allocation we get the new node. Now you have to traverse from the first nodes up to the node which data part is equals to your required data value. Here the value is 3. Let here V value is 3. Okay. So your after the completion of the while loop, your PTR, this is your PTR. So after the completion of the while loop, your PTR now is at this position. Okay. Now new nodes next is PTR. New nodes next is PTR. Let this is the first operation. Okay. Is it fine? This is the first operation.
Yes, sir.
And new node previous is pointing to the PTR previous. Or you can turn this as pre-PTR. So this is the second operation. After that, pre-PTR next. Pre-PTR next is pointing to the new node. Okay. So this is your pre-PTR. Pre-PTR. So this is your pre-PTR. Now, the fourth, what will be the fourth one? So PTR previous. So break this one, break this connection. And PTR previous is now pointing to the new node. So this is the fourth connection. So first connection is that. What is the first connection? First connection is that new node previous, sorry, new node next is PTR. New node next is previous. So this is the first connection. Then second one, second operation, what is the second operation? New nodes previous is pointing to the pre-PTR. Okay. And break this one. What is the, this connection can be denoted as pre-PTR next. So pre-PTR next is new node. So third connection is made. And finally, the fourth connection is that PTR previous, fourth connection, PTR previous is now pointing to the new node. Is it okay? Any problem? Please clarify. If you have any problems, please clarify. যে কোশ্চেন করেছিল বুঝতে পেরেছে? সমশ্রী মনে হয়।
হ্যাঁ স্যার।
Okay. Next, delete. So insert a node at any specified location, that is before and after. Before and after a given node in DLL. So you have to do this. Now delete. Delete from beginning. Delete from beginning. How to delete from beginning? So delete from beginning. Let the node is 5127346. Let this is the node, list structure. So how to delete the first one? Any idea how to delete the first one? First node, delete from beginning. So we have to take a pointer, temporary pointer, PTR, which is of return type struct node, and we copy the start to the PTR. Let the temporary pointer is PTR. We have to copy this start to the PTR. Okay. Next, we increment the start pointer from the present value to the next value. So start is equal to start next. Okay. So how to delete? Delete from beginning. Let struct node delete beginning. Delete beginning. So struct node start. One second. Delete from beginning. We have to delete the first node. So we have to copy the start or the first node to the pointer, temporary pointer, so that we use the free PTR. So the return type is struct node. And next, PTR is equal to start. Okay. And finally, start is equal to start next. Okay. And free PTR. Free PTR. And return start. Is there everything okay? Is it fine? না কিছু ভুল করলাম আমি এখানে? Please clarify. We have to delete the first one.
Sir, start previous equal to null হবে।
এটা কে বললো?
Somoshri।
Okay. So start previous. Previous is equal to null. Very good. Start previous is equal to null. Very good. Now, how to delete from end? How to delete from end? Any idea how to delete from end? So we have to traverse up to the last pointer. Okay. So up to the last pointer. So struct node delete end. Struct node start. Now we have to delete, we have to traverse and delete. So for deletion, we have to use the free PTR as well as we have to traverse. So struct struct node. Struct node. And next we have to initialize PTR is equal to start, and we have to traverse up to the last one. Sorry. While the condition is that PTR arrow next not is equal to null. PTR next not is equal to null. We have to traverse. PTR is equal to PTR arrow. Next, we have to traverse. Now you are at the last one. So we can easily write PTR arrow leave. The next part is made null. So you can use two pointer pre-PTR also. Next, free the PTR and can start. So this is the segment for from end. Now delete a node at any from any specified location in DLL. This is your homework, okay? And short the list, short the DLL. Now, up to this, do you have any query? Up to this?